The more work you have to do to justify a correct answer, the less likely it is to be correct.
Jason, welcome back to the MCAT podcast. How are you?
I'm doing okay. How are you?
I am great. Last week, we took it easy on you for your first episode here on the MCAT podcast. This week, that is gone. We are going to jump
into the Thunderdome.
We're going to jump into a biochem passage. This is from Blueprint MCAT Diagnostic, the half-length diagnostic that everyone gets for free at blueprintmcat.com. So go sign up for that free account. Get this half-length diagnostic. What is your ritual, Jason, for when you are jumping into the next passage or the next set of discrete questions? What is that ritual when you're like in between passages and you have to like scrub your brain from that disaster that just happened and hope this next one goes well?
Well, hopefully the last one wasn't a disaster. And really, you just have to put it out of your mind. You can only affect what's in front of you at the moment. So I don't really have a ritual per se. As soon as I start reading the next passage, it's all right, it's on. Here we go. And I'm doing what I've practiced, what I know how to execute in terms of starting to find the right information in the passage, knowing what I need to know in order to answer questions, accessing the parts of my memory that correspond to the content that the passage is talking about. So it really is just a hard cut to brand new thing. Here we go.
Yeah. Brand new. Here we go. Let's cross our fingers and hope everything works well. All right. So let's go ahead and jump into our passage. You'll read the passage, break it down like you would be breaking it down for one of your 2 T's.
Sure. So let's take a look at the first paragraph. So we've got the human digestive tract is fundamentally a long tube running right through the body with dedicated sections that are capable of digesting material put in at the proximal end and extracting any useful components from it, then expelling the waste products at the terminal end. This kind of paragraph is the sort of thing that I love to see as someone who is a little bit more in tune with the reasoning side of the MCAT than knowing everything about everything that there is to know about all these things. When a passage starts telling me something that I already know, I know I'm in good shape for that passage.
Oh, so here's a question, because a lot of instructors will say, take your outside knowledge and leave it there. Leave it at the door when you walk through the Pearson Testing Center, whatever the testing center is in the future. But it sounds like you're saying a little bit of the opposite here, where it's like, ooh, I know this. Like, this is physiology. I've taken 3 classes on physiology.
I'm on the lookout, certainly, for anything that might be new, anything that might be specific to this passage or the questions, anything that might be a little bit unexpected, anything that shows that the author might think things are surprising, certainly. But a paragraph like this, where it's just, let me explain to you how your digestive system works on a very, very basic level. 1 is not informative, and 2 is not testable, because they're not going to be like, well, which of the following best describes the human digestive system? It's a tube, it's a sac, it's a whatever.
Yeah.
There's just nothing in this paragraph that is testable, except for maybe the association of proximal and terminal with the 2 ends of the digestive tract. But even then, that's just a vocabulary thing, and that's not anything scientifically specific to this passage.
Yeah. Okay. Awesome. So for something like this, would you highlight anything here, or maybe just the digestive tract, because that's what this is about?
I mean, I don't feel like I'm in any danger of forgetting that this passage is about the digestive tract.
Yep.
So personally, no, I wouldn't highlight anything
Great.
in this paragraph.
All right.
The small intestine is the site where most of the chemical and mechanical digestion is carried out, and where virtually all of the absorption of useful materials is carried out. The intestines also have a smooth muscle wall. Take 2. The intestines also have a smooth muscle wall with 2 layers of muscle. This enables the generation of rhythmical contractions that force products of digestion through the intestine. To allow for absorption and secretion to take place, specialized zones known as macula communicans exist between the muscle cells. These directly connect the cytoplasm of two cells, which allows various molecules and ions to pass freely between cells. Actually, now we start to get into some new stuff. So here, a little bit more specific with the small intestine, and I'm noticing that they're giving us some specific functions. So I might highlight here chemical and mechanical digestion. Even though that sounds familiar to me, I still would like to be able to spot that quickly if the function of the small intestine or some reasoning about the small intestine comes up in a question. I might highlight smooth muscle, again, because that's something that I recognize, but I want to be able to reference it quickly. I want to be able to go back to the passage and go, oh, yep, smooth muscle, here it is. The new stuff is at the end of this paragraph. So we get a new term here, macula communicans, which kind of sounds familiar. Have you heard the word macula referred to in terms of the body before?
Yeah, in the eye.
Yes. So specifically, the condition called macular degeneration is just the degeneration of the retina. Macula in Latin means spot. So it's nothing more complicated than just a spot. And we have lots of different kinds of maculae in the body. The macula on the fovea of the eye is one, and here we're told about another one. So macula communicans, thank you scientists, thank you MCAT for giving this a really complicated name for a spot where communication happens.
Yes.
And they tell us specifically that the kind of communication that we're talking about, it's not cell signaling of any kind, it's actually just molecules and ions passing freely between the cells. There's our definition.
Yeah. Okay.
So in terms of brand new information, that's really all we get. We can expect to get some questions about what the macula does and how that relates to what you already know about the digestive system.
Okay.
All right. So this paragraph, oh, sorry, go ahead.
Yeah, no.
Yeah. So this paragraph was about the small intestine. We can imagine that we're going to continue through this long tube running right through the body. So the next paragraph talks about the large intestine. And in the large intestine, these connections, so we're still talking about the same kinds of connections, the macula communicans that we were discussing in the previous paragraph. These connections allow for the movement of ions and fluids. Okay, so that's something I want to take note of as I go. And then we get an example. So for example, if material is too solid, it cannot move fluidly and can result in blockage. Joy. To prevent this, chlorine ions are secreted into the lumen. Cations and water will trail the chloride anions into the lumen by passing through the intercellular space between the cells. This method of transport is in contrast to typical transcellular transport, where the substances travel through the cell. So I don't know, what jumps out to you as being particularly newsworthy in this paragraph?
I like the in contrast part of like, oh, this is different than normal.
Absolutely. So we're not talking about substances traveling through the cell. This is the intercellular space. So we think about like an interstate highway. We're going between two states. Here we're going very specifically in the space between two cells.
Yeah.
So that might come up. Yes. Yeah. Oh, yeah. We're taking the secret passage from the conservatory to the study and coming out the other side.
The conservatory to the study. Yes.
Got to get a clue reference in here somehow.
Yes. There you go. It was the butler
it.
with a candlestick.
Exactly right.
Awesome. Okay. So as we continue on here, So what would you highlight based on the contrast part? Would you want to do like specific big chunk here, or just the contrast part, and we can bring our eyes back to that whole section if we need to?
I think I would highlight the to prevent this chlorine ions, because that gives us the what and the why.
Okay.
So chlorine ions are secreted to prevent a lack of water. And then we're told exactly what the effect of that is. The cations and the water trail the chloride anions, which is to be expected. If we move a whole bunch of negative charge from one place to another, we can expect some positive charge to be attracted to that and follow. And of course, anytime we're moving stuff, water's going to follow that stuff. I say that all the time. It's really important in kidneys. Water follows stuff. So where there's more stuff, there's more water.
Okay.
And then, the last sentence, in contrast, I would probably grab, and substances travel through the cell. So a little bit different here.
Okay.
And then they give us a picture. And I'm going to be 100% honest. I'm not really sure what this picture is meant to show, other than what they've already told us. I'm not sure if this is supposed to be like a timeline where that first cell is early on, and then we open more chlorine channels as we go down. But it looks like, okay, chlorine can go from the basolateral layer to the luminal layer. And we also have sodium and chlorine exchange happening, going back and forth. But other than that, what does this figure tell us that the paragraph ahead of time didn't already mention? There's nothing new in this figure at all.
Yeah, I'm not sure. I'm not sure what it's trying to show, other than potentially just the graphics of the little box versus the circle. So the box being those special communication portals versus the normal transport, potentially, where the sodium and chloride are alternating there.
So this is one of those times where you don't want to spend 30 to 45 seconds looking at this picture going, what on earth does this mean? If a question cares about it, they'll tell you that we care about it, and they'll point you back at what you're looking for.
Okay.
But all things being equal, probably not going to be terribly important for the questions.
Yeah.
Just a picture. We've got one last paragraph to go. So diseases of the intestines are often due to chronic inflammation, which can arise from imbalances in the regulation of fluids and solute movement. Elevated levels of enzymes like thymidine kinase are often used to predict the risk of cancer in the colon. So here, what is this new paragraph about?
When this thing that they've told us about previously, things go wrong.
Absolutely. So the MCAT loves to take a system that works perfectly normally and break it. And then they go, well, what happened?
Yeah.
You go, MCAT, you broke it, and here's how, and here's what the result will be. So we're going to see a little bit of that in the questions. Whenever they start to talk about diseases, we can think about, okay, if I've got this disease, what effect will that have on the stuff that we've already talked about in the passage?
Yeah. And this is the perfect example, going back to previous episode where we talked about students spending too much time in content and not understanding how question writers think and how they write their questions and how they write their answers. When you're reviewing your content and you look at normal physiology, a good way of looking and reviewing that normal physiology is going, well, what if I put my finger right there and stop that thing from happening? Like, what's going to happen? What's going to back up, and what issues is that going to cause? And downstream it is being starved for these things. Like, what's going to happen? And I think being able to think through those things as you're reviewing content and not just scanning as quickly as possible to get through it, which is what most students do, is what makes potentially, in my opinion, a good MCAT score from a mediocre one.
Yeah, if you understand negative and positive feedback as concepts, you're ready for the vast majority of the kinds of questions that they're going to ask about. We've got a disease, it does this thing in the system, what result will that have? Well, either it's going to make something happen a whole lot more than you want, or it's going to make something happen a whole lot less than you want. And usually that sort of thing is going to be our answer.
Now we get to our questions. So, well, let's do a recap here. What do you normally do? You get to the end of the passage. Do you go, what the heck did I just read? Do you go, okay, I think I understood what I read. Let me just recap it in my mind. Or do you do what a lot of students love to do, jump to the questions and see what they want to know?
I usually take about 10 to 15 seconds to draw a circle around everything that the passage discussed, sort of in my mind, in terms of content, and wake up the synapses that connect to the content that might be relevant here.
Yeah.
So we talked digestive system in general. We took a trip through the small intestine, the large intestine, and then we took a little bit of a look at some problems that can arise.
Yep.
And so there's not a whole lot that's on the table in terms of content here. We got a little bit of maybe osmosis, a little bit of ion and cell transport. So I'm just trying to wake up the spreading activation and prime the all those concepts so that I'm ready to recognize them when they come up in the questions.
Yeah.
But I'm not spending a whole ton of time doing that. I just want to be able to say, okay, here's what I need to be prepared for. All right, let's do it.
Yeah. Okay. All right. So I'll go ahead and read the first question here. In which of the following cell processes does thymidine kinase most likely play a role? Thymidine.
Yes.
Thymidine kinase. All right. So now I go, okay, thymidine kinase is right at the end. That's where we talked about it.
Yes.
And so diseases of the intestines are often due to chronic inflammation, blah, blah, blah. Elevated levels of enzymes like thymidine kinase are often used to predict the risk of cancer in the colon. All right. So we have risk of cancer in the colon. We have to go back up going, okay, diseases, often due to chronic inflammation, can arise from imbalances in the regulations of fluids and solute movement, which is where we're going to get potentially increased levels of thymidine kinase. So how do we answer this question? All right, so answer choice A, osmosis, B, mitosis, C, translation, or D, conjugation. I think I'm reading those right. My font is very small as I'm reading this. So we know that cell transport and regulation of fluid and solute movement, that's where we want to go to. And so when we look at that, I mean, osmosis seems to be really the biggest answer choice here for if we have a disruption of this, we're going to have issues with this. I think it's just osmosis. I don't know.
So this is one of those cases where the passage was ultra specific here in terms of what thymidine kinase is implicated in. If they had just said also thymidine kinase plays a role, then we would expect it to be related to all the stuff that came above. But they don't do that. They say thymidine kinase is used to predict the risk of cancer in the colon.
Mm-hmm.
So that's the information that we should latch on to. What could thymidine kinase be doing if elevated levels are related to cancer? So very specifically, when we're talking about cancer, what are we talking about?
Well, we have a disruption in normal cell turnover, regulation, all that kind of fun stuff, which goes to not osmosis, but mitosis potentially, DNA translation kind of stuff, maybe. Interesting. So let's rewind a little bit and how I got to my it's osmosis, because we're looking at fluids and solute movement. Where's the mistake to go? We're talking about this, and then this comes in.
So it's ignoring the very specific information that they give us in that sentence. Thymidine kinase very specifically is related to cancer in this passage. And again, if they hadn't given us that specific detail, then we'd go back and relate it to everything that we were talking about before. We can also use what we know about thymidine kinase just as words to maybe figure out what might be happening. Thymidine is a lot like thymine. So when we're talking about thymine, we're talking about DNA, we're talking about bases. Thymine is the T of AGCT. Thymidine is that base plus its sugar. So it is very, very similar. We should also be aware of, for the MCAT, what a kinase is. What kind of an enzyme is a kinase?
I don't know. Like kinase to me is something that splits things, like it breaks things up.
So the word kinase has a very specific definition when it comes to enzymes. A kinase is something that's responsible for moving phosphate groups around. So we should definitely be aware of that. So now we've got thymidine, which is, all right, that has to do with DNA. We've got kinase, which is phosphate groups, and phosphorylation of DNA is kind of a thing, I guess, and cancer. So we're talking very specifically about unregulated cell growth and division. And if that's what we have to go on, because we're not going to read this and go, oh man, I skipped the chapter in my physiology book on thymidine kinase and I don't know what it is. What they're testing here is, can you figure out how it might be related to one of these things if cancer is the ultimate result of an unbalance in this enzyme?
Okay, got it. And I think, okay, so I tried to make some connections that weren't there, ignoring just, hey, enzyme, cancer prediction. Cancer is mostly unregulated. It's kind of cell growth regulation. I would go with B at that point then. And
B is the correct answer for this one.
All right. I was trying to get fancy with my critical thinking and reading, going, ooh, well, this and this and this. That's, I guess osmosis is the only one similar to that. But I ignored all the good stuff at the end.
Occam's razor applies here, right? So the simplest link from the passage to the answer is the best one. Okay. And I often say the more work you have to do to justify a correct answer, the less likely it is to be correct. So if we say, all right, this enzyme works with osmosis, and we know that because the passage is kind of talking about fluid movement, and we get a lot of information about that. No, proximity. We're told very specifically, thymidine kinase, risk of cancer. Go with that and use that as a simple tool for finding mitosis as your answer.
Let's keep rocking and rolling. Why don't you go ahead and read question 2 or 25 here?
Okay, so studies show that macula communicans are common, but not found in tissues such as the gallbladder and skeletal muscle. One possible explanation for this could be that these organs are ...
Okay, so go ahead and read the answer choices for those listening.
Yes, so not under autonomic nervous control is A. B is not involved in digestion of materials. C, not involved in secretion of materials. D, not involved in absorption of materials.
Ooh, all right. I like how they had to do gallbladder, so digestive tract, and skeletal muscle, not digestive tract.
Yes.
So not under autonomic nervous control. Well, the gallbladder, I think, is. Skeletal muscle is not. I don't think.
No. It is not.
B, not involved in digestion of materials. Well, skeletal muscle isn't. Gallbladder, again, kind of is helping us secreting stuff. Not involved in secretion of materials. Again, skeletal muscle is not. It's hard to find the answer when both of them are very different structures. So if we go to D, not involved in absorption of materials, well, skeletal muscle doesn't absorb anything, I don't think the gallbladder does that either, because the gallbladder is secreting stuff to help us absorb later on back in the small intestine, I think.
Yes.
And so to me, D is the only one that potentially makes sense here.
And D is correct.
Okay.
Yeah, absolutely. Your qualms about this question are well-founded, because ultimately, this question isn't about anything from the passage. It's not really about macula communicans. And it turns out, once we get into it, it's not really even about skeletal muscle, because skeletal muscle doesn't have any of these properties. Skeletal muscle is under somatic nervous control.
Yep.
So this question could very well be rephrased as, hey, what doesn't the gallbladder do?
Yeah.
And that's it. So we saw that the gallbladder is under autonomic nervous control. It is involved in digestion. And you even said, oh, it secretes stuff so that we can do digestion. And lo and behold, answer choice C, yes, it is involved in secretion as well. Mm-hmm. So the only answer that makes any kind of sense in terms of being something that is the intersection of gallbladder and skeletal muscle is D, not involved in absorption of materials. But really all we needed was, hey, do you remember what the gallbladder does? And you're golden.
Yeah, awesome. All right. And that's a good example of, like, I got to the right answer, not really sure what's going on here, but just trying to use some critical thinking to get through it.
The MCAT is a test about knowing what to pay attention to.
Yeah.
And that is a realization that I've had somewhat recently. Like, if I know what's on the table for the passage and the question, and I know what's important to think about for the questions, I should get every single one of these right. Because all I have to do then is put the right information together, and I've got the answer.
Yeah. It's that easy.
Now, that's not necessarily easy. Yeah, exactly right.
It's simple. It's not easy.
Yes. Yes, it is straightforward, but not necessarily easy.
Yep. I love that differentiation. Simple, it's not easy. It's simple. All right. Question 26. In patients with a certain medical condition, the intracellular path described in the passage is damaged in the large intestine, causing lower levels of transport. What change would be expected? All right. So just to recap, without going back to the passage, we know that we have this kind of intracellular path, this macula communicans, whatever it was called, that helps transport out chlorine, ions, anions, cations, one of those things, without looking at the passage.
Yes.
And it will then send water with it, right? Things are getting too mushy, too sticky. We need more water to help level
not
things
mushy
out.
enough is the problem.
Not mushy enough. Yeah.
I'm glad to be here for the discussion of this particular topic. Let me just say.
Yes. Hey, diarrhea and poop. I live for it. Let's keep going. And so, if there's a breakdown and we can't pump out what we need to pump out and get things mushier so that things flow, then that's what we're looking for. Which one of these would happen if we can't get that out there? All right, so increased Cl in the lumen of the colon. Well, we just said that's where this intracellular path, that's what it's for, is to increase those ions there. So that's not going to happen. And we're talking about the large intestine, which is also known as the colon. And so to me, answer choice A is not it. It's directly against that, I believe. Decreased Cl in the lumen of the duodenum. And I think this is one, it's like, oh, decreased. Yes, that's going to be the answer. But when you look at it, well, duodenum is part of the small intestine, and we're talking about the large intestine. So I think that's just a red herring. I want you to pick that one. Decreased waste fluidity in the colon. Ooh, not mushy enough. That's what I was looking for, right? Or increased waste fluidity. No, that's what happens when everything's working. We have lots of fluidity. So I'm going to go with answer choice C.
And that is correct. Yes.
Woo! And I got that by going, what do I think is going to happen, right? Kind of rewinding to what we were talking about earlier in terms of as you're reading stuff going, well, what if this breaks, right? Don't wait for the question. Know that there's probably a question that may be written about, well, what if this breaks? Well, if the whole goal of this process is to make more water come into the lumen so that things flow easier, if that breaks, then things aren't going to flow. And so that seems to be pretty straightforward.
This is a really good example of a 2x2 question. So half of these answer choices say increase, half say decrease. Half of them have to do with chlorine, half of them have to do with waste fluidity. So if we have a good idea of one of those two sort of valences, we can eliminate half of our answer choices. Now, it turns out here that like decreased Cl and increased waste fluidity, those are opposite words, but they do the same thing. They are part of the same process. So we have to be a little bit more careful here. But we can focus on, all right, what is sort of the valence of chlorine in terms of the direction that it's going? Oh, we're decreasing it. What happens to the fluidity? Oh, we're decreasing. So we're not getting enough chlorine and we're not getting enough water.
Yep.
So we are in fact decreasing both of these.
Yep.
So we can start with decrease and then think about it from there. Well, all right, what's the difference between these two answer choices? Because just decrease Cl, decrease waste fluidity, both of those are correct. What's the difference? Because they can't both be correct. Yep. And you notice there, like I got turned around with do I want an increase? Do I want to decrease? I've been doing this for a very, very long time.
Yep.
It's so easy to forget like which direction you want to go with things. This is one of those times where you might use that wet erase board to kind of jot down the direction that things are going. So we, from the passage, we increase Cl, we increase water. And now that this question says we are breaking something, we can go, well, it's going to be the opposite for each of those and make sure that we're keeping all of the increases and decreases straight, especially when we get systems where like increasing one thing decreases something else, decreases a third thing, increases a fourth thing. It's very easy to become confused, even if you know what you're doing.
Yeah. Okay. All right. Next question. Why don't you go ahead and read this one?
Yeah, absolutely. So which molecule is least likely to be able to travel via the macula communicans pathway? And we've got A, insulin, B, chloride, C, positive sodium cation, and D, lysine.
All right. So I think this is a game of potentially which one of these is not like the other.
Absolutely it is, yes.
And so I go, okay, I have a molecule of chloride, a molecule of sodium. I'm going to ignore the charges for now because I think that's just going to confuse me. I have an amino acid of lysine. Again, I'm going to ignore the charge. I don't remember. I'm going to pretend there's no charge there, even though I know that amino acids have charges. To me, those are potentially three small things.
Yes.
Insulin, if I remember correctly, not the smallest thing out there. And so to me, like, insulin is the one that just is not like any of the other ones because it is a large molecule compared to everything else. And
exactly right.
Not knowing anything else, that's the one I'm going to lean on and go, I'm going to trust my gut and go, I think this is just a game of which one of these is not like the others.
Yeah, so it turns out that A, insulin is the correct answer here. This is a great time where we can say, well, my gut says this, and I arrived at that very quickly. I still have 30 seconds for this question. I could keep going. And depending on how your pacing is going at this point in the section, you might very well say, I like A, I like insulin. Here's the reason. I'm going to move on. But if we do have, the 30, 45 a minute to evaluate our answer choices, and we're not running low on time, we can say, all right, let me see if I can demonstrate it. Let me see if I can find support for that. There is some very specific information about what these pathways allow through. What were the things that they said, oh, here's what we can get through?
Yeah, so we go back up here and we have ions and fluids in the large intestine. And then in the small intestine, molecules and ions.
Yes. So both of these say ions.
Yep.
And so we can say, all right, chlorine, sodium, they're out.
Yep.
Because we know that they're very likely to travel through these. In fact, we are told that those two things specifically in the large intestine pass through these pathways. So B and C definitely gone. And you mentioned, hey, I know that amino acids have charges. Lysine is free lysine. Any free amino acid has positive and negative charges. Lysine is positively charged under physiological pH. So lysine, as a small molecule that has a charge, can use this pathway as well. It's kind of funny. Insulin is a peptide hormone. It's made up of amino acids. It's a protein. So if lysine can't get through, insulin certainly can't get through.
Yeah.
So in terms of like our intuition and the support from the passage, yeah, we can definitely be 100% confident that A is our correct answer.
All right. Crushed it. All right. Question 28. The muscle of the dual layered system described in the passage is A, striated, B, multinucleated, C, regulated by the parasympathetic nervous system, or D, innervated by the somatic nervous system. All right. Some physiology here.
Yes.
So we highlighted very early on that this is smooth muscle. And so we just need to know what smooth muscle is. We know that it's not somatic nervous system. That's skeletal muscle. We were talking about that earlier. Multinucleated, I'm going to come back to. Striated is kind of the opposite of smooth muscle. So I'm going to get rid of that. That is a feature of skeletal muscle. Those Z-bands, aren't they Z-bands?
There's like 5 or 6 different letters. Yeah. There's an alphabet soup of letters in muscles.
Oh, I used to teach all of this stuff too. I would show how the myosin and actin would like pull and ratchet. It's been a while. All right. So we have multinucleated. We're down to 50-50 potentially here based on my gut. Multinucleated in choice B, or regulated by the parasympathetic nervous system. Okay, so parasympathetic or sympathetic nervous system, the autonomic nervous system here. Let's take for a second. We don't know which one it is. Can we potentially figure out the point and shoot parasympathetic, sympathetic? What's going on here? Yeah, I don't know. I'm trying to think of a way to potentially think about this to help the listener try to understand, get to that answer. Oh man, I'm gonna ignore that one. My random memory is like, oh, there's something weird about smooth muscles, how they're multinucleated. So I'm going to choose B just from that random old memory that I have, and hope that it's the sympathetic nervous system, not parasympathetic.
So the funny thing about smooth muscle and cardiac muscle is that they are both mononucleated.
Oh, darn it.
So multinucleated is a really great descriptor of skeletal muscle.
All right.
But the rest of your elimination here was right on point. Yeah, answer choice T is going to be it. And this question really is about two different body systems. You're on the hook for muscles and you're on the hook for nervous system. So here, knowing the difference between parasympathetic and sympathetic is really important for being able to eliminate, especially if you're not as comfortable with muscles, which typically we don't study those as much as sort of we would put into the different types of the different parts of the nervous system. It comes up here in biochem, and it comes up in psych-soc as well. So knowing those is definitely high yield. So if you're not sure about the muscle, you can think back to the basics of parasympathetic and sympathetic. So I always like to go back to, if you're a zebra and you see a lion on the savannah, what do you need to do?
Yeah, as soon as you mentioned, it's just like I go like, oh, like like sympathetic. We know is like you mentioned, right? The zebra and the lion. It's like fight or flight, right? It's like I'm gonna get ready to fight here. What do I need to do? And then the opposite of that is always that I don't know what the type of saying is. The rest and digest is parasympathetic, which is the stupidest thing. I'm like, it stared me right in the face, and I just right over my head.
Yeah, absolutely. So it's funny how like one tiny little thing that is applicable through a lot of different questions and two of the four sections of the test can be the difference. Having that general sense of parasympathetic versus sympathetic, and just knowing like, okay, rest and digest. Oh, digest. That's all we're talking about here. Is going to be the difference between a right answer and a wrong answer for this one.
Yeah, and I think this is a good example where there was something about multinucleated that I liked that answer, and so I stuck with that answer, and I didn't try to think about the other answer enough to go, oh yeah, wait, rest, digest, like, and so I harshly or quickly just went to the wrong one because there was just something about it that my brain liked more.
Yeah, just because an answer is deeper or has more detail or is like more scientifically rigorous doesn't necessarily make it correct.
Yeah. Oh, man. All right. Bummer. That's all right. So we've come to the end of our first passage. Again, for coming to the close of a passage, we'd mentioned it previously that even those who score really well in the MCAT come out not thinking the best. They're like, oh, I didn't do that well, and I know that I missed this question, that question, this question. What is something that potentially you recommend coming out of a passage to just kind of stop that negative talk?
If you're sitting in your cubicle on test day and you can look up and see like a blank wall or look up at the ceiling, like just the act of looking at something that has no detail whatsoever provides your brain with a moment of rest and can be a functional reset for going into the next thing. Take a deep breath, close your eyes. There are a lot of good things that you can do just to take 5-10 seconds, recenter, and be ready to move on to the next thing.